robotic manipulation just crossed a threshold. Instead of depending on brittle, hand-tuned policies, we're now seeing systems that can adapt across simulation, real hardware, and even entirely new embodiments. The big idea is not just more data or bigger models, it's alignment, making action spaces, object state, and training signals consistent enough that foundation models can actually transfer. That shift is what turns manipulation from a lab demo into something scalable. And the details here reveal exactly where that scalability is breaking through and where it's still surprisingly fragile. Let's explore the first paper, Object-Centric Residual RL for Zero-Shot Sim to Real VLA Enhancement. Object-Centric Residual RL for Zero-Shot Sim to Real VLA Enhancement, developed by CAST and Microsoft Research Asia with the University of Tokyo, shows that a frozen vision language action-based model can be made substantially more robust by a lightweight residual policy trained only in simulation. The core idea is to avoid the usual sim-to-real trap by letting the residual observe only 6 DOF object poses, proprioception, and the base VLA action, then aligning simulation and reality through teleoperation replay, so the sim VLA and real VLA share the same action distribution. The residual is optimized with TD3, augmented by hierarchical pose noise up to 5 mm and 0.1 radians plus 0.1 pose dropout, and deployed with foundation pose and SAM2 confidence-gated tracking. On 5 tabletop manipulation tasks on a Franca Research 3 robot cube lift, pick and place, stack cube, close drawer, and stand cup up, the method transfers zero shot and raises average real robot success from 42% to 76%, while also reducing successful episode length by 922%. The paper further shows the residual generalizes to a stronger backbone, π0.5, and that residual corrected rollouts can be reused to retrain the base VLA, creating a self-improvement loop without additional teleoperation. Let's explore the second paper. Play 2 Perfect What Matters in Dexterous Play Pre-Training for Precise Assembly. Play 2 Perfect, from Stanford University and Cornell University, argues that dexterous assembly should be learned by first learning task-agnostic play and then specializing with sparse reward RL. The policy is pre-trained with SAPG on procedurally generated cuboids and cylinders, using 6D key point-based pose control, random goal trajectories, and a tight 1 cm success tolerance to force in-hand manipulation rather than fixed grasp transport. Fine-tuning then maps CAD-defined assembly steps into sparse goal sequences via assembly by disassembly, including pre-insertion and threaded screw poses, while reusing the same robot prior. The key finding is that this prior is 33x more sample efficient than training from scratch, even against a dense, hand-shaped reward baseline that still needed over 100 hours to match the pre-trained policies for our result on simplified tight insertion. In simulation, Play 2 Perfect reaches 95% success at 4 mm clearance, 92% at 1 mm, and 80% at 0.2 mm, while the play-only policy collapses near 4 mm. Zero-shot sim-to-real transfer is demonstrated on a 2-2 DOF Sharpa hand with a 7 DOF Kuka, 2 14 arm, and foundation pose tracking, achieving 60% success at 0.5 mm clearance on tight insertion, and over 50% success on multi-part assembly and screwing. Let's explore the third paper, Qwen Robot Manip Technical Report Alignment Unlock Scale for Robotic Manipulation Foundation Models. Qwen team's Qwen Robot Manip Technical Report argues that robotic manipulation foundation models only scale when heterogeneous data are first aligned, then expanded. Built on Qwen VL and Qwen 3.5.4b, the system couples a vision language action backbone with a flow matching diffusion transformer and unifies manipulation under a canonical 8 zero-dimensional state action space, camera frame delta end effector poses, and in-context policy adaptation. The training corpus is assembled entirely from open source robot datasets and egocentric human videos, then expanded through a human-to-robot synthesis pipeline across 15 platforms into roughly 38,100 hours of pre-training data, alongside a 2.8M point vision language mixture. On OOD benchmarks chosen to expose genuine generalization rather than memorization, Qwen Robot Manip outperforms π0.5 across Liberal Plus, RoboTwin, Clean2 Rand, RoboCasa, 365, eBench, RoboTwin IF, and RoboTwin XE, with especially large gains in instruction following and cross-embodiment transfer. It reaches 72.2% on RoboTwin IF versus 49.6% for π0.5, 45.6% on eBench versus 27.1%, 35.9% on RoboCasa 365 versus 16.9%, and 23.9% zero shot on RoboTwin XE versus 7.5%. In real-world evaluation, the model also ranks first on Robo Challenge Table 30v1 with a 20% relative improvement and shows strong robustness on Agilex ALOHA, Franca, UR, and ARX, validating the paper's central claim that alignment is what makes large-scale manipulation pre-training transferable. That's a wrap on today's AI paper highlights. Thanks for watching.